Hi there. We talked in class about reflections, which is the second type of transformations. We learned earlier about translations. A reflection is when we take a shape or an image, and in some cases it might be a full shape like this, a quadrilateral. Other cases it may just be a line segment, but we flip it or reflect it over a line of reflection. Okay, and so in this case, we're going to be reflecting it over y equals -2. And now we know that a y equals a number line is a horizontal line. And so I went ahead and sketched in my line here at y equals -2. So that's going to be my line of reflection. And I'm going to be taking this shape and reflecting it over that. So we have two techniques for it. You can definitely count to the line of reflection. Q here is 2 from the line of reflection, so we'd count 2 on the other side, and that would give me that point, which would be Q prime. That strategy, though, gets a little tricky when our line of reflection isn't a horizontal or vertical line, when our line of reflection has some sort of positive or negative slope. It gets a little trickier to count. And so the other strategy we have is to use our patty paper. So I'm going to go ahead and take my patty paper, I'm going to cover this up, and I'm going to sketch in or trace in my shape. And I'm actually going to also write the names of those points. That way when I complete the reflection, I'll be able to see where my primes are going to go. And then the other thing we want to sketch in is our line of reflection, and I always like going from one side of the graph all the way across to the other side of the graph, being as accurate as possible, trying to keep this as still as possible, our patty paper. And the reason I draw in that line of reflection all the way across like that is I want something that anchors my patty paper once I've flipped it. If I just do a little piece of my line of reflection, it's quite possible that I'll accidentally slide my patty paper a little bit when I flip it, and that's going to skew my final sketch where my shape ends up. Okay, so now that I've sketched in my line of reflection, I started at one side of the graph and ended at the other side here. I'm going to go ahead and take my paper and I'm going to do the reflection, which means to flip it. And when I flip it, I'm going to line that line of reflection back up again from one side of the graph to the other. And that's going to give me, I can see now where my shape's going to be. Nice thing about patty paper is if you sketch really hard, trace really hard over the top of this, you'll get an outline. It'll be a light one, but you'll get an outline of where your shape should be. Right, so I can see here an outline, and all I have to do is darken it in and connect them. And then what do I name the points? Well, that's where putting the points on my paper comes in handy. I see here this top point is Z. I'm going to call it Z prime. And I see this point is E, so I'm going to call it E prime. And I actually stayed in the same spot, so it's just I prime right there on the line of reflection. And that's how you do a reflection. Okay, so we're going to do a couple more here. We're reflecting across y equals -x. This line here, y equals -x, our line of reflection is in y equals mx plus b form. My b, in this case, is 0, which is where I'm going to start. And my m is -1, which means I'm going to go down 1 over 1. Okay, which brings us to y equals x and y equals -x are diagonal lines. Okay, and so if I sketch that in, starting at 0, going down 1 over 1, start at 0, go down 1 over 1, I get this line as my line of reflection, going straight diagonal with a negative slope. Okay, and then same strategy. I'm going to go ahead and cover up this shape, sketch over it, and I'm going to label S, A, J, and T. And then my line of reflection from one corner of the graph straight through to the other corner. Reflection means to flip, so I'm going to go ahead and flip this. Line that line of reflection back up, one corner to the next. And then I can sketch really dark. And it gives me a little outline here. You can see that's J, T, S, and A prime. For my counters, those who prefer to count the line of reflection, with this one, since it's perfectly diagonal, we would be counting perfectly diagonal. Right, so J here, perfectly diagonal, is 1/2 of a box, and so J prime is going to go half a box on the other side. A is 1 whole box perfectly diagonal, so we'd go 1 whole box on the other side. S is 1, 2, 3 boxes, so we'd go 1, 2, 3 boxes on the other side. T is 1 1/2, so we go 1/2 and 1, 1 1/2 on the other side. And that's why I said the counting gets a little bit weird once you have any sort of slope to the line, positive or negative, because you have to compensate for that. Okay, last one here. On the front, we have reflecting across x equals -3, and x equals a number line like x equals -3 is a vertical line. Okay, so x equals -3 is the x-axis, x equals -3 is out here. There's my line of reflection. Okay, so same thing. Line this up. Sketch in the shape. We have I, P, W, and S. And then my line of reflection from one side of the graph all the way down to the other. I'm going to reflect it, so I'm going to go ahead and flip this shape over that line. Line the line of reflection back up again, one end of the graph to the other. And then sketch in really dark. So we have our W, our S, our P, and our I prime. All right, which is consistent with our shape here. W prime, S, S prime. And that's how you complete a reflection. On the back side, we were identifying in words what occurred here when we're looking at this transformation. And so when I'm looking at number 7, I noticed that my J and my J prime and V prime, it looks like this shape got flipped, right? Because the V was originally above the J, now it's below the J, as though it got turned over something. Same with the K here. The K was originally way down here below J, but the K prime ended up way up here above J prime, right? The shape has flipped. And if you had trouble seeing that, you could always take your patty paper and you could trace in your original shape. And again, I'd put in letters to help me identify where I'm moving. Actually, I think that's F, sorry. And then you can try to manipulate it. Try to get this V to land on top of this V prime down here. Right, well, if you try turning it, I can get the V to land on top, but the J is still down here, and I want the J up here. And so no matter whether you slide it or turn it or whatever you do, your V and your J can't get lined up the way you'd like on top of your V prime and J prime until you flip it. And as soon as you flip it, you can line it up perfectly. And so that fact that we had to flip to get it to line up means that this was reflected. So then the question is, well, what was it reflected across? Well, when I'm looking at my shapes here, I notice that going right through the middle of all these points is this line. J is 1 away, V is 2 away, K is 3 away, F is 1 away, right? That's that line right down the middle. What is that line? It's a horizontal line, so it's a y equals line. And that line is at y equals 2. Okay, so we're going to do the same thing here on number 8. We're looking, well, what's happened here? Our U was next to, or sorry, our U was below the T. Now it's next to the T. Right? Well, how did that happen? It got flipped. And again, you can take your patty paper, you can line it up, you can trace in your original shape so that you can see that flip take place. And again, I'd put in my letters just to make sure. And when I flip it, I can get my T and my U to line up on top of the T prime and U prime here. Right there. Okay, so I know since I flipped it that it's being reflected. And so then the question is, what is it being reflected across? Well, when I draw in horizontal lines, I can't find one that cuts these points in half, right? That's equidistant between T and T prime, and between U and U prime, and between V and V prime, D and D prime. And so if I can't find a horizontal line, I might try a vertical line. I'm not going to be able to find any that do that, so my last option here is, well, is it y equals x or y equals negative x? When I sketch y equals x in, y equals x goes this way, it cuts right through V, U, and U prime, but it doesn't cut through the middle, right? It doesn't cut the distance between U and U prime in half. It just goes through the points of U and U prime. However, when I draw in y equals negative x, which goes right here, that's halfway between T and T prime. It cuts right through V and V prime, which would make sense, right? When I flipped it, it would still stay on that axis. It's one diagonal away from U and one diagonal away from U prime, and then cuts right through D and D prime, which means that this is being reflected across y equals negative x. And those are reflections.